Hello friends, in this video we will see CMRR, common mode rejection ratio. Common mode rejection ratio, and it is given by ADM. ADM is differential gain upon ACM. ACM is common mode gain. Higher the CMRR means differential amplifier is going to reject more common mode noise. So it is good to have higher CMRR. Now for finding CMRR we need to find out ACM and ADM. So if we consider this topology, this is RL, this is 2IB, this is RL, this is RL. So first we will find out ADM. ADM we already find out for this topology is GM RL parallel RO, or we can write it as a GM RL in case RL is less than RO. So this is ADM. Here ACM, we need to find out ACM. So we will draw equivalent circuit for ACM by shorting input and outputs together. So here 2IB, this is VOCM, this is VICM. Now in this case our ACM comes as a 0. ACM equals to 0. Why? Reason is that first we try to find out its GM. How to find out its GM? So we will basically short output and we will find ISC. So this is our input, and now this is DC bias current. So DC bias current, when we are going to find out small signal DC gain, now this is, we basically replace voltage source by shorting it to ground, and current source by making it open. So this is open, so this is ID, so this is ID. Now ID is 0 basically, so because it is open, this is open, so ID equals to 0. So ID is 0. ID is given by GM into B ICM. This is 0. Now this is equals to ISC equals to minus GM. So ISC equals to minus. If ISC is 0, then ISC by VICM will also 0. So it means our GM for this circuit is 0. So GM equals to 0 because no current is flowing. If current is not there, then GM is 0. If GM is 0, so ACM is GM into R out, and if this GM is 0, so ACM is 0. Now common mode rejection is ADM upon ACM, which is GM RL divided by 0 equals to infinity. So in this topology we have CMRR infinity. Now let's find out, this is first. Now let's find out CMRR for this kind of circuit. Okay, this is R tail. This is VDD. Now for this circuit we need to find out. Now in this case, when we find out, this is say RO, this is RO, so this here RL is infinity because current source is having infinite resistance. So we already find out ADM is GM RO parallel RL. Now RL is infinity here, so ADM equals to GM RO. So this is our ADM. Now we have to find out ACM. For ACM, this is 2IB. Here this is R tail, and this is VI, this is VO. Now let's find out ACM. So for this topology, GM is GM of this circuit 1 plus GM R tail. Now for output resistance, so this is RL equals to infinity, so only this cascade structure R out we need. So R out equals to GM R tail GM RO R tail, because this will be like this. We are finding R out, this is R tail. So in this way we are finding, this is cascade structure, so this will be R out, and ACM equals to GM into R out, which will be equals to GM 1 plus GM R tail into GM so this will be equals to GM RO R tail. Now suppose GM R tail greater than 1, so it will be equals to GM RO ACM. So CMRR equals to ADM upon ACM. This is GMRO, this is also GMRO, equals to 1. So in this topology, CMRR is 1. Why? Because this term is greater than 1, so GM will cancel and R tail will also cancel, so GMRO will be ACM. So now we have seen for this topology CMRR equals to infinity, for this topology CMRR equals to 1. Okay, so yeah, I hope CMRR for these topologies are clear. We will see generalized CMRR formula, on which factor it depends. In next video we will see this. Thank you.